Good afternoon, everyone. Welcome to our first, well, not the first, but the first one in this week of our educational webinar series. And I'm very happy to introduce to you again Angelique Runacre from Fujifilm. She's going to tell us more today. So, Angelique, the floor is yours.
Okay. Can you see my screen okay?
Yeah.
Perfect. Okay, so yep, I have the privilege of kicking off the summer series of the RadTech webinars, covering two topics here. Very brief overview. You'll be pleased to know that there's following webinars that are going to do a much deeper dive, things like equipment, chemistry and market. But here today we're just going to spend a few minutes looking at applications, that the breadth of applications that we consider in RadCure. Some of the trends associated with those, and then what that means from a very high level formulation perspective. So I can't take credit for any of these slides. These are RadTech slides, but I think this introduction is really good. I've been working in Fujifilm for 25 years now on inkjet ink formulation. So sometimes my world is quite specific in terms of RadCure, and it always surprises me. Even now, after 25 years, I'm still finding new applications that are being complemented or achieved by RadCure products. So I think this quote by Paul Dufour in 1989 is still very much applicable today, that the applications are too diverse for one person to name them all. And I think this illustration on the left-hand side of the slide is very good too. This could be anyone's Saturday or Sunday off work. You get up from your bed, you go and sit down. You've moved from one piece of furniture to another piece of furniture that's been coated with a UV or an E-beam coating. You pick up a book at breakfast or a magazine. Again, that's been printed or coated with UV or EB printing materials. You go out somewhere, you pick up your shoes, you pick up your bag. Some of that decor, some of that synthetic feel will have been achieved by a RadCure product. Later on, you might watch TV or listen to music or look at your iPad. All of those electronics, display screens, many of those now are being achieved with UV curing methodology. You might decide to do a bit of sport later. So if you get out your fishing rod, you know, quite often those rods will have composites that are made with UV application. Maybe it's a protective varnish. And then, you know, finally you might sit down for tea. You might go into your cupboard and pick out a few products ready to cook, and the variety of different packages there, all printed with UV or EB curing inks and varnishes. And maybe you've got indigestion. You might pick up your paracetamol or something, and then again, those pharmaceutical packets have been printed quite often with a RadCure product. So it's all around us, and this is really just trying to set the scene for how many different applications we have to consider when we talk about RadCure products, and what that then means for our formulation considerations. So that example there we just went through in our daily life, we're looking at so many application areas. We've got information on those medicine packets, maybe the newspaper we read. We've got decorative in terms of our home furnishings. Protection, you know, we might have those sports equipment protected by UV curing. And then constructional, many different things there we've perhaps done throughout the day, walked on or been part of. And then functional, there might be other things that we've done, maybe gone to the dentist, or, you know, picked up something that's got a unique application done by RadCure. And this is just a graphic that illustrates the point. There have been RadTech innovation series over recent months and years, and most of these topics just seen in this picture have been covered. For example, membrane switches, circuit boards, solder resists, rapid prototyping. So do encourage you to take a look at any of those webinars or content that are of interest. if we look at the breakdown of applications for Radcure products, I think this is a very good slide also. It's obviously data pre-COVID. There may be some slight change, but I think if you look at those broad areas, it still holds true. So industrial coatings and overprint lacquers are the predominant use of energy curing products. Then you have electronics, printing inks, and others. If you think about the UV-EB Radcure market globally as a whole, it's pretty broad brushstroke fair to say that Asia has the biggest market, then the European and Middle East areas, and then the Americas in terms of volume. And there are also geographical differences within that. So, for example, in the Asia region, printed electronics is much larger than other applications. Whereas if you look at America and Europe, the biggest impact is things like industrial coatings, wood flooring, things like that. So let's go through some of these application areas, look at some of the challenges and some of the trends that are happening in these areas. We'll start with the biggest one, which is industrial coatings and overprint lacquers. So as you can see, wood and paper is the largest part of this volume. So things like floor coatings, things like IKEA furniture, these things can be quite often aqueous UV based, using polyurethane dispersions and things like that. Then we have the plastics, the optical, the electronics, as we see there. That is the fastest growing application area, particularly as electronics is becoming more and more part of our life. And then you've got metal and construction. So if you think about coil coating, they're looking there for Radcure products to reduce their cost. If you look at decorative, things like decorative cans, they're looking there to use new processes such as inkjet, for example, that can bring you personalisation to your existing processes at a reasonable cost still. So what are the trends within this segment? In terms of growth, it's really becoming quite global. And as I explained, water-based UV systems are expected to grow, both in terms of industrial coatings, but also graphics applications where you can get the benefit of an aqueous technology and a UV technology. And e-beam is also under consideration. People are looking to see where they can really implement this technology. In terms of technology shifts, again, we've spoken about consumer electronics becoming big in Asia, but also photovoltaics. Germany and other places within Europe are becoming quite highly involved in that. And UV is now being looked at as a way to reduce production costs, whether that's a way of eliminating some of the extensive drying you need with solvent or UV, or actually taking steps out of the process. Sorry, the cost of solvent and aqueous. And regulatory is, I think this is a theme across all industries, particularly for industrial coatings. You've got to consider things like global registration. So we have REACH registration requirements. We have organisational bodies such as for the printing ink, it's UPIA, that actually are doing due diligence in health and safety and telling us raw materials that we can and cannot use. And more countries, even smaller countries, are starting to put their own registration programs into place. Obviously, VOC restrictions and sustainability, lots of things we'll come on to in some of the other areas. The next biggest segment is printing inks and overprint varnishes. And here you've got an overview of all the different kind of technologies that are utilising printing ink. So you've got from lithographic, flexographic, screen, letterpress, analog processes through to the digital. And you can see some of these are declining or increasing depending on technology. So for example, flexo is increasing. The cost and quality and speed is getting much closer to allow it to attack other traditional print methods. If you think about screen printing inks, conversely, they're declining as things like flexo and digital printing become much more cost effective, much more environmentally friendly, and just, you know, particularly, for example, digital printing, you've got the added benefits of personalization, short runs. High gloss OPVs are declining. That's mainly because print in general is declining. People are reading less magazines. Whereas conversely, OPVs for packaging, so packaging varnishes, are increasing because packaging is a big growth area. This kind of summarises some of the things I've just mentioned. So the key driver to the printing ink trends, which technology is increasing in popularity and usage and which is decreasing, is coming down to productivity and quality. So people need to reduce their printed product cost. So that can be that certain ink technologies allow them to print faster, or it might mean that they need less energy to actually cure that product, or they might be able to do away with a production step. So they might not need printing plates if they're printing digitally, for example. And again, print quality, it's reducing the gap between flexo and offset, and also the gap between inkjet and flexo. So it's really the game is changing. And functionality is getting better. So things like challenges that we've had in the past, we're now starting to overcome. In terms of a technology shift, for food packaging, there's a lot more flexible packaging now. And that, you know, it can be advantageous for different curing regimes. For example, EB curing can really keep up with those flexible packaging line print speeds. Changes in flexo and wet flex, and as I said, digital inkjet is becoming of increasing interest. Regulatory, as with industrial coatings, it's having a big impact, particularly with printing inks, where a lot of printing inks are being used in food contact applications. We have to consider indirect food contact. So there are a huge amount of regulations and legislation about formulating printing inks for those processes. And the big one, sustainability. Recycling is a big thing, because actually the amount of ink on a product is not that big, but it's, if that ink can stop you from recycling your product, then it becomes a big problem. Also with sustainability, things like setup, so substrate can be a big consideration in your carbon footprint. And if you're running a huge, really high speed offset press, your setup, you could be wasting a huge amount of substrate compared to an inkjet process where you've got much less setup. So there's a lot of considerations here. And renewable materials is a big thing, and it's lovely to see in the Runacre market that we're starting to have many of the key raw material suppliers introducing equivalent raw materials for us ink formulators that are using materials that are sourced from bio products rather than fossil fuels. So hopefully that will continue to grow. At the moment, it's quite cost sensitive, but I guess as economy of scale moves forward, that could become more accessible. And then we have other application segments. So these are, if you remember on the pie chart, much smaller volume, but much more diverse. And I guess they will grow as Runacre technology continues to evolve. For example, rapid prototype modelling and manufacture. Quite often now we'll be buying a product off eBay that might be an aftermarket part, for example, that's been 3D modelled. It's really becoming quite an interesting area. And again, the breadth in this area. So even fingernail cosmetics are UV curable products. Our fillings, as we know, are UV curable products. So we've seen, you know, a whistle-stop tour of the diversity of Runacre applications that are out there. This slide is really to bridge the gap between talking about application and talking about formulation. So we've got just 4 examples here of different market characteristics. And I want to draw your attention to the top and the bottom sections here, because just by way of an example of the differences that these applications put on how we approach formulation. The top example is an automotive coating. So we're talking here perhaps about a car. We've used maybe an overprint varnish, or we've used a special effect pigmented ink, something to get, we might have used something to cover the headlamps coating. Could be anything on that car, but it will have to have these high performance requirements. So if it's a windscreen shield, if it's the black around the edge of the windscreen, it's got to have sufficient opacity to achieve that functionality. It's got to be thermally stable. You can't just sell a car in England. You've got to be able to sell it in Florida. You've got to be able to sell it wherever. And it's got to have this good colour strength. And when we buy a car now, we're used to things like paint guarantees, warranties, and these really have to be absolutely tight. Otherwise, we could be in for a huge financial loss. Whereas if you take something like printing inks at the bottom, here the requirements might be different. You might have a packet of I don't know, packet of crisps. It might only need to last 6 months on a shelf, or probably even less with the shelf life of the product. So it doesn't need to have these highly light fast pigments, this high durability. But what it does need is to ensure that that product stays safe. So we have to make sure that the ink is formulated, that it achieves food compliance requirements. And also that the product, the printed product, the quality is visually acceptable to make someone want to buy that product. And then within printing and inks, you've got things like security printing, where you might need to have things like fluorescence or infrared built in to your product. So you can see just these 2 different application areas, both Radcure products, are completely different in how we approach formulation. And the story gets more complicated. So with formulation, you've got formulation in the middle, you've got the user requirements on the right. So what are we trying to do? Is it a wood product? Is it a printing ink? You know, what's the application? Then down the bottom, you've got to consider what's the equipment. You know, how do we achieve that functionality in a way that's got the right productivity and the right quality to give us a financially viable application. Then pointing down from the top, you've got health and safety considerations. So this is all the things we have to consider in a Radcure formulation. And what we have to play with is that stack of rectangles on the left-hand side, the raw materials that go into our formulation. So we're going to talk about those in a little detail. But first, in terms of trends with formulation, I think it's fair to say that we are moving from a heavily analog into more of a digital world. And that does mean that the ink formulation requirements or coating formulation requirements are becoming different. Typically, we need lower viscosities. Typically, we're applying higher film weights. We're needing lower pigmentation. And that can have an impact on cure speed with some of the new technologies. This means that how we formulate can have a different effect. So when you think about a lot of the analog processes, you're using, on the left-hand side there, you're using oligomers to really build your properties in. Whereas on the right-hand side, this is less the case. In the right-hand side, we're using more of the monomers to build those properties. So we're going to discuss these various components now. So this is a basic formulation composition. There will be more detail, I'm sure, in other presentations. And not all of these components are needed. For example, you have your oligomer, which is your main film former. And as I said, depending on whether you're printing via a spray, via a screen, via an inkjet, whatever application method you're using, that will control how much of that film forming material you can include. So you can see the wavelength there can be from 5 to 80%. That's why it's so varied. The same with the monomer. You know, this can be, in a low viscosity system, your main contributor to the performance of the coating, whereas in a high viscosity system, it might just be used as an additive to control viscosity, to keep it constant. Radcure products generally need a photoinitiator, although with e-beam curing, that may not be the case at all. Although in some cases, you might need a small amount of photoinitiator to control your ink spread with some sort of UV pinning. Pigments, self-explanatory. Active ingredients can depend on your application. So it could be, for example, printed electronics. You might need to ensure conductivity or avoid conductivity. Stabiliser, again, is important, and additives to improve those properties. So we're just going to look at 3 of these really in detail. That's the oligomer monomer as one area, the photoinitiator, and then the stabiliser. Just to keep it simple, and the aim of this is to show how you need to consider your application with your formulation design. So the first area is oligomers and monomers. So dependent on your type of coating, those in combination will be the bulk of the coating, and they will give it the film properties that it needs. So on the left hand side here, you can see oligomers, so resins. You know, they can be various types: epoxies, urethanes, polyesters. They all have different properties, but fundamentally molecular weight can impact on those properties. So if you have something that's low molecular weight, you're going to have very low viscosity contribution. So you might need to use those if you're formulating an inkjet ink. But a low molecular weight material is also going to be pretty low for reactivity. It's going to be pretty soft. You know, so it's not going to be very branched. It's not going to have a lot of cross-linking potential. So there is a trade-off there. On the positive side, you know, it hasn't got many cross-linking sites, so it's going to give you flexibility and adhesion. On the other hand, if you picked a high molecular weight oligomer, you might pick this for something like a protective varnish for a rigid material. You want something that's really cross-linked, really high molecular weight, really good for protecting that material, really good scuff resistance. And you might not be worried about flexibility or viscosity. And on the right-hand side, you see some examples of monomers. So monomers are acrylate diluents. We categorise them depending on the number of carbon bonds they have available for cross-linking. So a monofunctional monomer will have one site that can be opened to join, whereas a trifunctional would have 3. So you can imagine a monofunctional monomer, when it's joined to form a polymer, will be a much looser, more flexible system. But it won't be as highly reactive and as high hardness as something with a higher functionality. So we have to really balance the monomers and oligomers for the process we're coating with. That's driven by viscosity. And then we have to balance it based on the application requirements. So what is important for that application? And as you can see, quite often it's a trade-off. Photoinitiators, these are the workhorse of Radcure, certainly for UV, mercury and LED curing. They're the ways of really opening those bonds on the monomers and the oligomers and joining the film together. Obviously with e-beam curing, you're using electron energy to achieve that. And the key thing here is that we match the photoinitiator to the radiation source we're using. So for example, if it's an LED radiation source, then you have one wavelength of light. So you want to make sure your photoinitiators are absorbing and reacting in that wavelength. If it's a mercury lamp, you've got multiple wavelengths, which allows you to create a photoinitiator cocktail to act on all of those different areas of energy. So The type of photoinitiator, as we say there, they exist in a solid, liquid and polymeric form. The combination and the amount we would use depends on the application. So what type of wavelengths do we have available for us? The type of photoinitiator. So again, if it's an indirect food contact application, you might be working with polymeric photoinitiators, higher molecular weight, so that they're less likely to migrate through the system. And as I said, the absorption wavelengths. That absorption wavelength is critical to match it to the UV energy source and to balance it, so you're hitting cure all the way through that coating. And there are other factors. For example, some photoinitiator combinations can be joined together and they form a liquid. Two solids can form a liquid, and that may be very advantageous for your manufacturing process. And as we said, again, with e-beam curing, you are relying on another method of curing, of generating those bonds between your monomer units. Here's just an illustrative example of how you have to be careful selecting your photoinitiators. This is a relatively old example. We wouldn't want to be using 369 for health and safety today. But you can see, if you look at the colours, if you look at the white, for example, that's got a very different photoinitiator package to the yellow, red, blue and black. So with the white, again, we have a different absorption range of the pigment itself that we have to try and maximise with our photoinitiator, so it's not competing with the pigment. We also have to make sure we're using photoinitiators that are low yellowing, because a white will tend to go creamy if you put, for example, too much of TPO inside. If you look at the black and the blue, you can see there in this example, they've got 369. That's really, again, because these dark colours, you've got to make sure you've got photoinitiators working at these long wavelengths to allow you to get that through cure. And you can see as well that some photoinitiators there require the use of an amine synergist. So EPD has been added into those formulations. And in general, you can see there's a mix of chemistries there and absorption peaks to give us that cocktail working across a standard mercury absorption wavelength. And the final additive I wanted to talk about is stabilisers. These are really key to RadCure products. We know that not only do we have photoinitiated free radicals that can start the polymerization process, but we can have thermally induced radicals. And it's important that we control those in terms of shelf life of the product and also performance on press, as well as during manufacture when you could have potentially thermal hotspots. And there are many examples of stabilisers here. Some stabilisers work in the presence of oxygen, some work in the absence of oxygen. So it may even be necessary to get a mix to ensure your product is robust. And we could go on, we could talk about additives, we could talk about so many other things. But as I say, this isn't a deep dive, just to give you a feel that formulation is driven by application. So in summary, we can see that RadCure applications are wide, they're diverse and they're growing. And the main advantage is instant cure and solvent free. And, you know, when we think about the new drive towards sustainability, RadCure clearly has a place in reducing carbon footprint significantly compared to aqueous and solvent-based technologies. However, there are disadvantages. Some of the things listed here, it can be more odorous compared to aqueous technologies. But these are gradually being overcome. And I think one example is this viscosity constraint. Go back several years, it was difficult to achieve the film properties that you needed in lower viscosity products such as Flexo and inkjet. But now that technology is there, and these applications are starting to be achievable even with Flexo and inkjet. UV and EB radiation is created by electrical energy that can be sourced as eco power and not reliant on fossil fuels. So again, another sustainability benefit. And as we mentioned, we're starting to see now more bio-based materials. So I think, you know, even in that summary, we can see that the market requirements are still changing. So let's continue to keep discussions going within the rad curing industry and look to be innovative. So I think that's really where we can carry on working together and supporting the RadTech conference and organisations. So I hope that's been informative, very high level, lots of broad statements there, but hopefully it's really given you a flavour of what's to come, and happy to answer any questions.
Thank you so much, Angelique. So indeed, we now welcome any questions. If you have a question, you can click on the Q&A button. I do see already 2 questions from Ophelio. Can you say some formulators of coatings for this technology, for paper or wood coatings?
I must admit, Ophelio, it's not an area that I'm active in. I would recommend really just a basic internet search. I think would give you some very good steers on that point, because it is such a big industry. I'm sure there are some key players that will come up very obviously.
And I see a follow-up question. What about excimer technology? But I guess that would be then the same.
Yeah, I think with all of these, there's a lot of technologies now coming through for rad cure, eczema, also things like the UVC, LED sources. I think that's really all these things are areas where, again, I'm no specialist, but we should all be looking at them and seeing how can this push the boundaries of what we can achieve within our relative industries.
Yeah. All right. Just allowing a bit more time for people to type in any questions if they have any. I also would like to say that this webinar was recorded, so if you would like to listen to it at a later time or want to forward it to someone else, then that's possible. We will make the recording available on our RadTech Europe website. I think your presentation was very clear, Angelique. We have no questions. If anyone comes up with a question later on, then also feel free to contact us. We will be happy to answer your questions later. So then now, Angelique, thank you very much again for your presentation. And now they're coming in. All right, so the first one is, what is the best alternative for TPO?
Well, I think it depends on what you're trying to achieve. So, for example, so if you're trying to achieve indirect food contact, for example, you might pick a polymeric TPO. If you're trying to achieve lower yellowing or less photoinitiator content, you might want to pick something like BAPO, which is both very similar molecules, because TPO is very good for through and surface cure. It's quite a workhorse of photoinitiators.
All right. And the next question is from Toma. We might have polymerization during storage. It happens more often in bigger volume packaging, like 200 kilos. Which is the worst, the lack of oxygen inhibition or the high pressure? In our printing ink experience, the ink to airspace ratio can be absolutely critical for storage stability. So, and funnily enough, it can work in both ways. Sometimes having a lot of oxygen is a good thing, and in other times it's not so good, depending on your chemistry. So I think you could really look at headspace and see whether that is giving you any effect. You know, is it that
that oxygen inhibition going on, because in one package you've got a different headspace compared to another. In terms of pressure, I'm afraid it's not something I have any experience with.
All right. Allowing a little bit more time. But I guess that was all the questions for this afternoon. Thank you very much again, Angelique, and thank you to all the participants for joining us today. I hope you also will join us during the next webinars in the following days. And yeah, I wish you all a very nice afternoon.
Bye.
Bye.